Now continuing with inertia, just now we have told that inertia can be classified into two main categories. One is inertia of rest, another is inertia of motion. So I am giving few examples of this one. Many examples are given in your book and one or two questions will be coming in your exam related to inertia. So before going into those questions, remember, inertia is the property which is totally controlled by mass of a substance. Remember, inertia is directly proportional to mass. More the mass, more the inertia. Less the mass, less will be the inertia. In other words, you can say that more the mass, more force is required to a body which is at rest to take that body into motion, and more force is needed having the body having more mass in order to stop that body. So inertia is directly proportional to mass, and inertia is the property which totally depends on mass of a substance, mass of a body. So related to inertia of rest and inertia of motion, there are many examples given. So I am telling few things to you. Say this is an example. I will show you what are the things you should write in the exam in order to answer this type of question. And I am assuming this is a 3-mark question. And see here, a cardboard is placed on a glass and I have put a coin on that cardboard. So if you just put a force, remember very quickly, if you apply a force, you can see this card will fly away and this coin will drop into the glass. Again, I am repeating the situation. Let us assume this is a glass and I have put a cardboard or any card on it, and on that cardboard I have put a coin and I have put a certain force. And remember, this type of force which you apply suddenly on a body is called impulse of a force or impulsive force, which we will learn in class 10. So if you apply the force, the card will fly away. The card will be here, but you can see the coin will be dropping into this glass. This phenomenon only takes place due to the inertia. How to explain it? See, when no force is applied, both coin and the card are at rest. So first point I am writing, when no force is applied both coin and the card are at rest. Remember. So what property they are having? Inertia of rest. Now I have applied a force on the card, not on the coin. I have applied the force on the card. As a result, the card will be in motion. So when force is applied, see how I am writing, when force is applied on the card. This is a keyword, not on the coin. So card, the card will be at motion. The card will be at motion. Now see, what about this coin? The coin previously at rest. So it tries to be in a condition of rest. So third point I am writing, the coin which is at rest, tries to be in a state of rest. So this card is going away due to inertia of motion, and the coin which is placed on the card tries to be in a state of rest. So what will happen? The card will fly away, and due to inertia of rest, the coin will drop into the glass. So after that, after writing this, I will show you the keywords. So you should write it due to inertia inertia of rest, the coin will drop. The coin will drop in the glass. Remember this one. Now see, in this type of question, you have to mention the inertia. This is a keyword. Inertia of rest, another keyword. Inertia of motion, another keyword. And depending on the situation, depending on the example, what they have given, you have to answer those conditions, answer those questions. There are many questions related to this. It is given in your book. An athlete takes a long run before a long jump, because when he is in the run, the athlete gathers inertia of motion. That inertia of motion carries that athlete to a certain distance. So, in order to remove dust from the carpet, we have to beat the carpet. Why? When we are beating the carpet with a stick, the dust particle on the carpet will be at inertia of rest. But when I am applying the force on the carpet just moves. As a result, the carpet and the dust particles will separate. As a result, the dust will fall down. Now see here, you can take many examples. When a bus suddenly starts, see, when a bus suddenly starts, a passenger passengers tends to move backward. How it is going on? See here, I am assuming this is a bus and one person is standing on that bus. When the bus starts moving, suddenly the lower part of the body of that passenger start moving. Why? Because it is the lower part, that is the legs are adjacent with the bus. When the bus or any vehicle starts moving, the lower part of the body of that passenger starts moving due to inertia of motion. But what about the upper part of the body? Upper part of the body was at rest and it tries to be in a state of rest. Now see, this portion of the passenger are in motion and this upper part tries to be in a state of rest. So definitely the passenger will be like this. He will fall backward. Exactly same thing when a passenger jumps from a moving train or a moving bus, he tends to move forward. Why? When he is jumping from the moving bus or a train to a stationary, to a ground is at rest, the lower portion of that person will be at rest. But due to inertia of motion, the upper portion of the body will be at motion. So the passenger just fall in the forward direction. So these are few examples of inertia of rest and inertia of motion. Go through those examples. In this type of question, remember, you have to mention what type of inertia the body is having, what type of inertia the body tries to retain, and what are the consequences of that.